Alright, today's integral, we have the integral from 1 to 2024 of the floor of log base 43 of x. Now this whole problem just looks really ugly, like we got the floor, we got an unusual base log, what are we supposed to do? Now with a floor function, we know how floors work, it basically just means round down. So if we have like 1.5, that's floor of that is just 1. You have 2.2, floor of 2.2 is just 1. So we want to find the values that that will split the log function base with floor. So when does log base 43 of x, when is that going to round to 0? When is it going to round to 1? Now we know of log of a base, if you plug in that base to the log, then that just equals 1. So in this case, we have log base 43, so we know log base 43 of 43 equals 1. So because of that, I'm going to do an integral from 1 to 43. I'm just going to break this into multiple integrals. And so between 1 and 43, everything in between there is less than 1. Because log base 43 of 43 is 1, everything below that is going to be less than 1. So because of that, floor of something less than 1, that's going to equal 0. So the integral from 1 to 43 is going to equal 0. So integral 1 to 43 of 0 dx. The next integral, we're going to have to start at 43. And we want to find next when does log base 43 of something equal to. And the answer to that's going to be log base 43 of 43 squared. The reason, because just log base 43 of 43 squared. You remember your log properties. If log of a to the power of b, you can just bring the exponent out front. And this will just equal 2 times log base 43 of 43. We said log base 43 of 43 earlier was just 1, so this will equal 2. Because of that, our next integral is going to go from 43 to 43 squared. And everything between these values is going to be between 1 and 2. So because of that, floor of anything between 1 and 2, remember it just rounds down. So this is just going to be of 1 dx. And next we would just do the same thing, go up to 43 squared, or 43 cubed, my bad. However, 43 cubed is going to be greater than 2024. So this last integral is just going to go from 43 squared to 2024. And this one will be of 2 dx. Now integrating these, this is really simple. This whole one was 0, this is just going to go away. This next one, this is just x from 43 squared to 43. So this will be 43 squared minus 43. This integral, this is going to equal 2x from 2024 to 43 squared, or 43 squared to 2024, my bad. So plugging this in, 2 times 2024 is going to be 48. And I'm going to leave it as minus 2 times 43 squared for now. So now I'm just going to simplify slightly, and then I'm going to simplify it slightly without expanding these 43 squareds, and then we'll just get it to our final answer. So we have 43 squared minus 2 times 43 squared. So this is just minus 1 43 squared term. Also minus 43. And this part is 48. This is going to be a lot of longer math. 48 minus, this was, I believe, I already forgot. I had this written down earlier. So this part's just long math. Minus 1849 minus 43. So I'm just going to add these two parts together. So this is the same as 48 minus 1892. And subtracting these will give us our final answer. I'll just write this up here. This equals 2156. So the hardest part is going through and splitting up the floor function, and then you just got to go through some longer arithmetic stuff. So if you don't have that fully memorized like I did for the video, or as you wouldn't for an actual integration bee, you just got to do some longer multiplication and stuff, subtraction by the side. But overall, it's not too bad of a problem.